do is the way I want to do this is I want it to be interactive first of all. Okay. So it's not like just I'm saying something and then I'm the only one talking. I don't want that. So in between, I'll be asking questions, and I would expect participation from the audience as well. Okay. So and the other thing, like I was saying, that the course contents will be mixed between biomass energy systems, sustainability, and a little bit of renewable energy. So I'll just go through the course contents. The first lecture, that is today, it will be the basics of sustainability. Then I'll cover a little bit on circular economy, and then an overview of renewable energy, and then a discussion on the Indian electricity system and the sustainability of the Indian electricity system, basically. Then we move on to the biomass part. So after the first four lectures, the fifth one is the introduction to biomass energy systems. Then we have the biochemical conversion processes, and then we move on to the thermochemical conversion processes, where we'll be talking about the biomass properties, principles of combustion, torrefaction and pyrolysis. Then we move on to gasification, and then to alternative fuels, and then we'll try to understand. There are two, three things that might be very important that we may use in the future. These are, until now, what I told you, are just information that you can find even in the public domain, maybe, right? But there is this analytical ability of performing the mass and energy balance of any system. Now, most of you are from mechanical engineering, so you might know what mass and energy balance is. You may think it's trivial. Some of you may think it's trivial, but yeah, even if it is trivial, it's very important even for the industry, as well as even if you go into academics. This is the first step of any process or any system, basically. So mass and energy balance is very important. So we'll try to understand mass and energy balance through gasification systems. Okay, because that's what I'm working on. And then we'll go into techno-economic assessment and life cycle assessment. So I'll try to do the last part, that is the mass and energy balance, techno-economic and life cycle assessments offline. All right. So maybe that can be done. Okay. So this is basically the course that I have planned. And for the final assessment, like I said, we'll have like two parts. One is the activity based on the contents of the webinar, and then you'll have the seminar. So we'll have a discussion uh, for within the next 2-3 days, and I'll circulate the instructions for the final assessment. Okay, so I think I'll have about 11, 12 lectures online, and then after that, maybe 1 or 2 days offline, along with the final assessment. So that's the plan. Okay, so I'll just share my screen. One second. Can you see the slides? Anyone? Are you able to see?
Yes, sir, we can see it.
Yeah, okay.
Yes, sir, we can see them.
So basically, let's go through sustainability first. Okay. So what is sustainability and why it is important? All of these things. Okay. Okay. So can anyone explain to me what sustainability is? What you think sustainability is, based on whatever you've read, or what's happening here? Yeah. Can you just unmute yourself and talk, because I can't go backwards and forwards, between the chat.
preserve the existing resource.
To preserve the existing resource, that is one thing, and
To preserve some existing process without
Proceed.
too much harm on the
One at a time,
surroundings.
please. Yeah. Continue.
To preserve the current processes and like functionability without harm, without too much harm to the surroundings and also the living things around it.
Okay. So you're talking about processes. So it's not processes actually, but it's you mean to say resources, is it?
Yes, sir. Resources
Yeah.
and well processes which use these resources.
Yeah. I mean, see, the processes could be changed, right? Based on how things change, the processes could be changed. Because see, earlier we were using coal, right, extensively. So that was the process. Because like let's say 100 years ago, no one knew that okay, coal is depleting or it's causing pollution or they didn't care. So over the years, people realized this, and then came in global warming and climate change and all of these environmental sustainability viewpoints. And then we changed the processes, right? Like we tried to include more of renewables in the last few years, you know. So the processes can be changed. Okay. Yeah. So, but the resources, like okay, if we extensively use resources without taking into account, like you said, the surroundings. But there is one point that you missed, that is intergenerational justice. That is without taking into account the future needs, right? The needs of the future generations. Okay. So that is the definition of sustainability given by the Brundtland Commission in 1987, where they said that sustainability is nothing but you can use your resources, but in moderation to ensure that you meet your own needs, but also leaving enough for the future generation. Okay, and that is one of the most important definitions of sustainability. And there is a key phrase in this, that it should satisfy the needs of all stakeholders. So who are the stakeholders in literally anything that we do? So who are the stakeholders? So you have the society. Society is a major stakeholder in literally anything we do, right? So if we are implementing a project, let's say we have let's come back to power plants itself. So let's say we are building a thermal power plant in a place, or let's say we are mining coal in a place where there are a few villages. Okay, the major stakeholders are the residents of those villages, right? So we can't just displace them and then say that okay, we are going to mine coal so that you know we can provide electricity so to some industry to create more jobs. They are also stakeholders, but the primary stakeholders are these villages. We can't displace them. Another major stakeholder is the environment. The environment. So if we are polluting more, if we are using a lot of resources, then of course we are mm, harming the environment. So that's not a good thing. Then we also have one more important dimension of sustainability, and that is the economic dimension. So we also have to think about if we are going for green alternatives, what is the cost of it? So that is basically affecting the consumers, or that's also affecting the society in another way. Okay, so these are basically the stakeholders. We need to um, take care of all the stakeholders before we think about moving forward in any way. And this is sustainability. But one more important stakeholder is the future generation, which not a lot of people talk about because they are not visible right now. So we need to talk about that as well. So, like I was talking about the dimensions of sustainability, right? So there are three dimensions. Majorly, there are three dimensions. Okay, one is economy, the second is the environment, and the third is the society. So you need to think about profits for reducing costs, that is one of the most important things. Although profit is now a swear word. Okay, a lot of organizations think that profit is a swear word, which is not the which should not be the case. Okay, because without profits, without money, you cannot have a system that works. Then, of course, the environment. A lot of discussion is happening around the environment, and the third is the society, which I just explained about. Okay, there are some studies that also include an institutional dimension, that is governance dimension, where you have different policies. Let's take for example climate change itself. Okay, so there was this policy of the National Solar Mission, basically 10 years, 15 years ago. Okay. At a time when solar electricity was costing about 17 rupees per unit. Okay. But the government decided to go ahead with this mission. And then for the next 4 or 5 years, it didn't reduce as much. It reduced to maybe 13, 12 rupees, around that much. But then after that, there was a huge boost of technology innovation, basically, and cheap modules coming in from China and Vietnam and all these places, and that kind of drastically dropped the electricity tariffs. Okay, right now the tariff is around three rupees, less than 3 rupees, in fact. Okay, so it's even cheaper than thermal power and yeah, coal-based electricity. So that's how much powerful a policy, a well-implemented policy can be. So right now it's more beneficial for us to go for solar rather than coal-based power. So yes, but there are two ways you can do this. Either you can have these three dimensions, you can analyze these three dimensions: economy, and environment, and society. How any action is affecting these three dimensions, and based on that you can suggest policy to the government. Okay, this if these policies are implemented, this is how it will affect these stakeholders, basically. Or you can have the institutional dimension within the policy, it's within the analysis itself, and then you can come up with a sustainability score, right? Right. So what are the criteria? How do you measure sustainability, basically? So you have these dimensions which I just talked about. You have certain themes, sub-themes. I'll explain this through a case study. Actually, that way it will be much easier. Okay. Themes, sub-themes, composite indicators, and then finally indicators. So these are key performance indicators that you come up with. And then you have to justify these indicators, and then they'll go into some composite indicators, and then eventually the sustainability score will be calculated. Like it's a hierarchical framework. So coming to science, technology, and sustainability, right? So how do technological innovations affect sustainability? But before I move on to this, let me ask you this: what is the difference between invention and innovation? Can someone answer this? Question is what?
Invention is,
Yeah.
sir, invention is creation of something that's completely different and new. Where innovation is
Can you just
improving the
speak up? I'm
existing
not able to properly hear you.
Hello.
Yeah, yeah. Yeah, please.
Yes, sir. So invention is the creating of new things, like completely new. It wasn't invented before, and innovation is improving what is already existing.
If you improve something that exists, that can also be an invention, right? Like, let's say an efficiency improvement in a process. Okay. Through something that you have invented. Let's say that, or let's say you're adding what kind of example can I give? Okay, let's take automobiles, for example. Okay. So improving the efficiency of the automobile by by, let's say, improving the spark plug or something. So that spark plug, what improvement you have done is an innovation, right? Or is an invention, right? But yeah, but you're improving improving an already existing process. So basically, innovation cannot be done without invention, right? Can,
Sir,
yes, anyone? Yeah,
sir, invention is like he previously said, invention is creating something that did not exist before. Innovation
right.
is something that where an invention is refined and it is used as an application, as a solution to something, or
Yes,
to
absolutely.
as a
That is
new
the
process.
that is the right definition. See, invention is something that you can invent something. It can be on paper itself, right? It can be an idea. It can be a process. It can be, let's say, a prototype, but it has not come to fruition. It is not being used. So that is basically an invention. Innovation is something that is out there in the economy. It is being purchased. It is being used by common people. That is an innovation, right? So basically, how do these how do technological innovations affect sustainability, and which stakeholders are affected by these innovations, and how are new technologies introduced in the market, right? So this is what we're going to see. So we have the in normal, value chain, let's say. Okay, so you have raw materials which use conventional technologies. Okay, so these conventional technologies use natural resources. Okay, to fulfill people's needs and aspirations, and that leads to economic growth. So this is how it has been happening since a long time, right? So, what are the positives and negatives of this kind of a linear kind of thinking? One is that it leads to depletion of natural resources because of the extensive use of raw materials. Okay. And then it leads to pollution and emissions because of inefficient technologies and polluting technologies basically. But the positives are that when people's needs and aspirations are fulfilled, it leads to human development, and that leads to economic growth and more jobs. Okay, so these are the positives. It's a positive for the society, but then it's negative for the environment and the planet in general. Okay, so there is an example just in the next slide, but can someone come up with an example for this um, line of thinking, or basically, I mean, you can just yeah, anyone. um, yeah,
Sir, steel industry.
yeah, can you give the example in the context of this flow chart basically?
Okay. So
Yeah,
the raw materials are the iron ore,
right,
and the technologies used to refine the ore,
right.
and then people who uh, come and work there in the industry, and
Right.
like in refining the ore, and then there will be economic growth, more jobs are created. Like the once the
Hmm.
everything is refined, it will be used in different industries, like utensils
Hmm.
making, and in
Yeah,
automobile industry, and it will create more jobs, but that will that will also create more pressure on the natural resources.
sure. Can you give me an example of how it is causing pollution and emissions, especially I mean, you said steel industry,
Yes,
right?
sir. In
Yeah.
refining the materials, refining the ore,
Hmm.
it requires a lot of water, so it will pollute
So
the
you're
natural.
talking about extraction of the ore for the refining, right? Or for the steel production, right?
Yes, sir.
Not the production of steel itself.
Yeah. Even
Okay.
in the beginning only, it will require a lot of water, and
Yeah.
in
That
the later stages also, it will use a lot
okay.
of water.
Okay. So basically, let me tell you, this is absolutely right what you said about extracting the ore. But during the steel production, what happens is you have to, so it is in the form of Fe2O3, and you have to reduce it to iron, right? So that is basically your iron or steel production process basically. So how do you
Huh.
reduce it? So the industries
Using
normally
coal
use,
actually.
yeah, exactly.
Yeah,
They use
using coal
coke,
actually. Yes.
yeah,
Yes, sir.
char
Yes.
or charcoal or coke basically. And what happens is the coal kind of reacts with the oxygen to form CO2, and it
Mhm.
reduces the iron ore to iron. So this is the basic, very simply explained process. This is what happens. And
Yes.
5 years ago, we had a seminar here, hydrogen seminar, and the MD of, or I don't know, it was a GM or someone of Tata Steel had come here, and he was joking that we're producing CO2 and steel as byproduct. So that's
Mhm.
how bad it is in the steel industry, because for every ton of steel produced, they produce 2 tons of carbon dioxide. Okay.
Yes.
And
Yes.
that is the reason they want to go to hydrogen, because instead of coke or instead of coal, they want to use hydrogen, so that the byproduct is just water, right? Water vapor or whatever it is,
Yes, sir. Yes, sir.
right? Instead of CO2. Okay.
Mhm.
So yeah, you're absolutely right. So one more example is, transportation, let's say. Okay. So we are using petrol and diesel for our vehicles, which require crude oil, and that leads to depletion of crude oil. But that increases the facilities for transportation basically, which leads to human development and economic growth. Of course, people need to go to their work and schools, colleges, and so on and so forth, right? That
But
leads
in
to
the
more
process, it
jobs.
leads to depletion of natural resources also.
Yes. Yeah, depletion of crude oil basically, and more demand for
Yes.
crude oil because of the economic development. Okay. So this is a very
Yes.
linear way of thinking actually. Okay.
Yes. We are not giving back to the nature at all in this process.
Absolutely.
We're just
Absolutely.
taking
This is
from it.
this is this is how it has been for the past 150 years or so. Okay.
Yes.
Right. So we were talking about innovation. So what is innovation, and how do we? What are the um, the process? What is the process involved in the innovation itself? So first, you have an idea. Okay. So like someone said that you want to improve a process. Okay. Or improve a product. So that is also innovation. But if you want to introduce a new product or service in the market, that is also innovation, right? So you have an initial idea of how you can do this. There needs to be a basic research. Okay. There needs to be, so what is basic research? So you're just establishing the science of your idea. So let me ask you this. Let's say that you have an idea, and you say that, okay, all these vehicles, they are moving. So they're using petrol and diesel. So once they start moving, I'll just have a fan or something in front, or maybe on top of the vehicle that is facing the front. Okay. Once they start moving, the vehicle is like gaining speed, and because of that, there is wind movement in the opposite direction. So that will kind of move this fan, or let's say a turbine or something like that. That will generate electricity. I'll store that electricity in a battery and then move the car itself. Is that a valid idea?
No, sir.
Why not?
It won't be that efficient, I think.
Think about, like I said, the basic science of it. Think about the basic science.
It won't store enough energy in order for the vehicle to use it on a large scale, on a large on a large scale, right?
No, no, it's not about scale at all. Right now, we are at basic research, right?
Mhm.
So
Okay.
when it comes to basic research, I just want to know how scientifically applicable this particular idea is. That's all.
Yeah.
Okay, there is a very specific term for this kind of machine that I'm proposing, there is a very specific term. You would have heard this, okay, but you might not remember the name of that. So when basically what I'm proposing is, so once you start your car, it will never stop, right? I mean, if you want it to keep moving, it will keep moving. So that's the idea, right? So because the wind, that is because the car is moving in the front direction, right? The wind is moving backward. The wind kind of the energy in the wind is stored, and that kind of moves the car. There's a very specific word for or a phrase for this kind of a machine. So what is it?
Perpetual
Exactly,
motion.
Perpetual
exactly.
machine.
Yeah, yeah. Is it possible to create a perpetual motion machine?
No, sir.
Unless you give energy from somewhere, some outside energy, it's impossible to create that, right? Right. So that is an
Yeah.
example of an idea that won't work. So that's why basic research is important. Okay. Then you come to the applied research, which is basically, I mean, you are establishing the technology itself. Okay. Will it on paper, will it work? I mean, the basic research you have established saying that, okay, scientifically it will work. Okay. But what are the technological aspects of it? Okay. So that is the, one second, just give me a second. Yeah, so basically that is what applied research is. Okay. Then you come to the next stage where you kind of develop this like a prototype or something. Once you have established the applied research part that, okay, technologically it will work. So you come to the design and development, and then you do the engineering for manufacturing. So the prototype is ready. You know that it works practically also. So you need to scale it up. So you need to manufacture it. You need to release it to the market. Okay, and then so that's how you get a new product into the market. But there are, this is a very simplistic idea of how an idea is turned into a product. But in reality, there is a lot more to it. There's a lot of depth to it. So there's something called TRL, technology readiness level. Okay, so if you are coming up with a new technology that is not commercial yet, that is not in the market. So there are levels from 1 to 10, TRL 1 to 10. So 1 is the initial idea, 10 is like totally commercial, 7 is somewhere in between. So 7 is basically where you can implement it or release it to the market. So something like that. Okay. And there are pilot plans, demonstration scale plans, all of these things come in that. So, but it's not very easy to just, create a product, have an idea, create a product. It has to come from somewhere, right? The motivation has to come from somewhere. So as they say, necessity is a mother of invention. In this case, innovation, right? So the motivation comes from the society. So they have some social wants. Okay, let's say some new industry or something. Also, one example of social wants is, let's say a few years ago, someone had this bright idea that people are very lazy to go outside or to cook food or just go outside and have food in the restaurant nearby. So they came up with this idea that, let's give them these mobiles, have an app, and then the food will just come home. Right. So no one knew that this was a social want, but apparently it just caught on. And another idea is, Uber, Ola, all of these cab aggregators. That was a real social want because one, the public transportation is not very widespread in many of the cities, and two, um, even if you say, okay, there are autos and other modes of transportation, it's not very reliable basically. But this kind of was a game changer in the Indian market, right? So, but not all these needs are transmitted. So some of these are filtered. So there is a study that argues that most of what the urban population wants is what is transmitted as so basically anyone who can pay for the technology or the service. in the product or the service. So if they have some wants, those kind of wants get transmitted. Let's take rural India, for example. So as of now, um, the productivity of rice, of paddy cultivation. So in India, it is about 2.5 tons, 2.5 tons per hectare. So that is how much rice we are producing. That is a yield of rice. In China, it is 10 tons per hectare. So there is a fourfold difference between India and China. So why are we not innovating there? Like, okay, the innovation is there, of course. It has improved from the 1990s, say, but it's moving at a snail's pace, and that's because it's not actually impacting, the richest of the rich, or or even the urban middle class, so to speak. Okay. So that's, yeah. So then we have the transmitted demands. Okay. Then based on the available technologies, if the technologies are available, then it just comes to a different loop. It's using the available technologies, these products and services already exist. Okay. But if it does not exist, it goes to, the innovation process, basically through the institutions, the educational and science and technological institution, and then new technologies are brought out into the market. It could be new technologies or new services. Like I just gave you the example of the food delivery and the cab aggregators, and then that comes into the market. Okay, so this is basically how the society interacts with any technological innovation. Now coming to corporate sustainability. Okay, so I talked about the dimensions of sustainability, right? So there are three dimensions: so economic, environmental, and social. So, so the corporations also have to think about these three dimensions. So in their case, it is profit, profit, planet, and people. Okay. So, and there is something called the triple bottom line approach. The first earlier approach was just the profit model, where the corporations used to think only about the shareholders, anyone who had a stake in the company or its products, or basically anyone who has invested in the company. Okay, but now people are talking about this triple bottom line approach, which thinks about profit, planet, and people. Okay, and we consider stakeholders here. Stakeholders are anyone that has anything to do with the company at all. So a few minutes back, we were talking about the people in a place living near the coal mine or something. They are also stakeholders in this project of coal mining, right? Okay, the environment is a stakeholder. Okay, we cannot just pollute the environment. That is a stakeholder. The employees are stakeholders, and so are the customers. So are the vendors who sell some of their materials to this company. So literally the entire chain. So are the stakeholders. So there is this concept. Okay, the carbon emissions. There are different scopes of carbon emissions. Does anyone know about these different scopes of carbon emission that capture this very beautifully, actually? There is scope one, scope two, scope three. Anyone? Does anyone know about this? No? Okay, I'll just tell you. So when you take a company, for example, any activity within the company premises that leads to carbon emissions directly comes under scope one, that is direct emissions. And then there are indirect emissions, of course, based on the upstream and downstream activities. And the upstream activities, for example, includes the purchased electricity, for example, or if you have purchased uh, heating and cooling or something, and then goods and services, capital goods, and all that. Okay. Downstream activities will have, if you have a share stake in some other company, for example, that is downstream for your company. Okay. there are leased assets, there are end of life treatment of sold products, and then of course what happens to the product once you have made it and then you've sold it and someone else uses it. Okay, so what happens in this case is you will just say, okay, that is not my problem anymore. It is out of my premises. So that's not the way you think about it. You have to have a life cycle thinking, right? So this is basically scope one, scope two, and scope three. So scope one is basically the direct emission. Scope two is whatever electricity and energy that you're purchasing from outside that you're using still within the premises. Scope three is the upstream and downstream activities, right? So wait 1 second. Yeah. The next one is next. So we move on to wait urban sustainability, and in this case study, I'll be explaining how a sustainability assessment can be done. Okay, so using the indicators and the criteria that I had mentioned earlier in the presentation, right? So this is a case study carried out by Dr. P. Balchandra, who's a professor here at the IIS at IISc. Both of them, in fact, Dr. Sudhakar Reddy as well. So they are in the Department of Management Studies. Okay, and this study evaluates the present pattern of urbanization in India and then compares it with global cities. So they've compared two cities in India, Mumbai and Bangalore, with I think yeah, Shanghai, London, and Singapore. Okay. So then it is, yeah, the comparison is made on the dimensions of sustainability, economic, environmental, social, and they've also included a governance parameter, right? And benchmarking has been done. So I'll explain how the benchmarking is normally happening. Okay. So what is the methodology of uh, as of the sustainability assessment? So first you have to design the indicator based framework. So you have to come up with the set of indicators that will accurately measure the performance of any city or any region, for example, or any project for that matter. Okay. And you have to screen the indicators, you have to prioritize these indicators, and then you have to quantify them. So for example, let's say that in a city, what is the carbon emissions from a city? You can't measure the carbon emissions directly, but let's say the amount of diesel used for transportation in a city. So that is easily measurable. So that can be one indicator. Climate change can be the composite indicator. So I spoke about composite indicator, right? So one of the indicators under this composite indicator can be diesel consumption. The other one can be electricity consumption within households. Okay. In the social dimension, let's say, for example, how much poverty is there in the city? Just examples. So all of these are quantifiable indicators. They can be quantified through secondary reports and studies. Okay. Then we come to the normalization. So why do we do what is normalization first, and why do we do it? The normalization is basically you're converting any indicator that you have quantified to a dimensionless value between 0 and 1. So why do you do that? So let's say you are comparing climate change with poverty. So they are not comparable because they have different units. So poverty can be percentage of the population or something. Climate change or global warming potential will be the amount of carbon dioxide emitted. Okay, how do you compare these two indicators? How do you know whether the city has performed poorly or well in one of these indicators? So then you just do the benchmarking. How do you do that? You take the actual value, you take one maximum and one minimum threshold value based on a global audience or global kind of system, right? And then so let's say there is a best city when it comes to climate change. Okay, so you take that city, how much CO2 is emitted in that city, or how much diesel that city is using. Okay, compare it with that city, and then you take a worst city. Okay, and then you just normalize it using this formula. Okay, the actual value minus the minimum threshold value by the maximum minus minimum, and that will give you a normalized indicator value between 0 and 1. Okay. And now it becomes easy to compare. So now let's say the poverty is between, let's say, 0.8. Okay. That means the city has performed very well in terms of poverty. Like it has reduced poverty quite a lot. But in terms of climate change, it has scored, let's say, 0.4, which is not very good. Okay, only 40%. So that way it is easier to compare, right? And easy to suggest policies as well. Okay. So once we do that, the composite indicators I just told you about, and then finally the overall sustainability index can be developed. Okay. Then then you have the yeah. So then you have to do the aggregation of these indicators and composite indicators. Okay. So that can be done through arithmetic average, geometric average, or root mean square. Okay. And then, so just talking about the indicators and composite indicator, right? So, for example, you have the per capita income, income distribution, and then you have the city GDP, for example. Okay, all of that feed into one composite indicator called income. So you can measure the income performance of the income of that city using these three indicators. All right. So, can someone give me an example of, let's say, social indicators that can feed into one composite indicator? So this is one example of an economic indicator, right? So I need an example of social indicator. Anyone?
Sir, am I audible?
Yeah, yeah.
Yeah. Can it be education?
Yes, absolutely. The education is an indicator. Okay. So let's say you should have at least two or more indicators to feed into a composite indicator. Okay. But education can also be a composite indicator. Okay, let's consider this as a composite indicator and let's go for the indicators. What will you measure in education? Can you tell me that?
The literacy rate or something.
Yes, that's one indicator. Yeah. Anything else? I mean,
Other
we
than
need at least one
education?
more indicator that can feed into education, right?
Like the percentage of graduating or educating population moving
Yes.
on to technology or such
Oh,
fields.
no, that becomes something else actually. I mean, you're talking about what percentage of the educated population has got jobs. So that will go into jobs actually.
Mhm.
That won't be education, but there's something called gross enrollment ratio. Have you heard of this term?
Ha, ha, ha. Out of
Yeah.
the
So gross,
population, what percentage is joined into the
yeah, yeah.
education?
Yeah, someone says dropouts. Yes, absolutely. So basically, gross enrollment ratio is so what percentage of the school graduating population has gone to college? Okay, so currently it's about 25 to 30 around this range for India. Okay, there are some states that have performed really well above 40, and I think the maximum is Tamil Nadu. I think it's around 47, 47 or 49 for Tamil Nadu, if I'm not mistaken. Okay, so yeah, so these are some examples, and then let's come to the actual, the indices. Okay, so let's say economic. So is this legible? I mean, this slide, you're able to see, right? Yeah. Okay. So you have in the economic framework, you have income, growth, then consumption, infrastructure, and transportation. In the social framework, yeah, demographics is also one thing. Education, yes, education we were just talking about. Health, equity, and safety, and access to basic needs. So let's talk about, let's say, health. Okay, so what could be one a couple of indicators for health? Anyone? You're talking
The
about a
mortality
city
rate,
right now.
Number of
Hmm?
the mortality rate, sir.
Yes, maternal mortality, or let's say infant mortality, whatever it is. Okay. There are a few more. Let's say, for example, the number of hospital beds per thousand population, number of doctors per thousand population, all of that. Okay, that is also quite important. Okay.
The air quality,
Air
will air quality
quality.
come here?
Say air
Like
quality
that
might
will
not come
affect
under
the
health.
that will
Actually,
affect the health, right?
yeah, it will have affect the health, yes, but the air quality will come under the environmental framework. You can see air pollution here if you go to the environment. Okay.
Yes.
So that is affecting the health. That is absolutely certain. But then that is an environmental indicator. Okay.
Yes. Yes.
So in environmental framework, you have all these air pollution, global warming, and soil pollution, water pollution, urban green spaces, energy consumption, and water consumption. So these are composite indicators or themes. Okay. So under these, there are many indicators. So you basically come up with the difference between an indicator and a theme or a composite indicator is that the indicator is easily quantifiable. Okay, either through secondary data or through primary research. Okay, and over here you can see that the comparing Bangalore, Mumbai with the other three cities. Okay, so you can see that the best performance has been for which one? I think, yeah, Singapore has the best performance of 0.773 overall performance. Okay, and I think Mumbai has the least. I mean, our Indian cities, they're not performing really well in terms of sustainability, but yeah, Bangalore has performed reasonably well, but this is an old research actually. This is from August 2013. So back then, there were not as many problems as we are facing today, I feel. Okay, especially with respect to, let's say, water scarcity and all that. Okay, so I think this research has to be updated now. Okay, so I think your HOD mentioned that you have a course on sustainable development goals. So I'm not actually going into the details of it. So the SDGs will be one of the seminar topics. So if anyone would want to take it, you can. So I'll be circulating the same seminar topics shortly, right? So there are 17 goals. So if you have any experience with the SDGs, maybe through self-study or through the course, you can just come forward and talk for a couple of minutes. So each goal has a few targets, and in fact, just recently, I think about a month back or something, Niti Aayog has released the new numbers for this year, and I mean we have performed quite well. India's, I think, 71 something. That is the score out of 100. Which is quite well, and there are only a couple of states that have been left behind in terms of overall sustainable development. But I find it a little hard to believe, to be honest, because the reliability of our data is quite questionable, in my opinion. It could be also true. I mean, I'm not questioning it completely, but yeah. So, anyone has anything to contribute in this? Anyone? No? Okay,
No.
so yeah, please go ahead.
No, sir, nothing, nothing.
Okay, okay. So I didn't put any I mean descriptions into any of this. I just wanted to have a discussion on the SDGs. Okay, so we'll go into the Q&A right now. So if anyone has any doubts or would like to ask some question, you can ask. But I have some questions after this, which I'll be asking, and then you can answer. So if you have any doubts or any questions, you can ask right now. Anyone?
Sir, do you have to make any report on biomass energy system webinar?
So like for the final assessment, I was just thinking that there'll be two. I'll come back to you with the exact requirement for the final assessment. Okay, but there will be two portions of it. One is an activity based on. There'll be some questions based on the webinar topics. Okay, and what you need to do is you need to solve it. It will be in a group. Okay, you'll be given like 2 3 hours, whatever it is, and then you can in your own group you can just discuss and then you can solve these questions. That will be the activity. And the second one will be the seminar. Seminar, there'll be different topics based on biomass itself or based on sustainability or renewable energy, whatever it is. Okay, there will be different topics that I'll be giving out, and each group will form the groups also. So that will be again based on the participation in this webinar. So right now I can see 109 people, right? So I don't know how many people will be interested to go through this, but if you need the certificate, you need to have perfect attendance. I'm recording the attendance in Teams actually. And the second thing is you need to attend this final assessment, either the activity or the seminar. So you can choose between the activity or the seminar. Okay. So I'll let you know the details in a couple of days.
Sir, seminar and activity, it is online or from the college only we have to do it? Like,
Actually, I'm planning offline for that. So I may
sir.
come to your college anyway. I mean, the professors have been inviting me to come do a couple of sessions. So maybe one session I can do there. I mean, the last session or something, and then based on that, there'll be an activity maybe on the same day or the next day, and then after that the seminar. So the details are not clear yet because I mean we need to know how many people are there and how to form the groups, and then we'll give the choice to each group saying, okay, do you want the activity or the seminar and that kind of stuff, right? So
Okay,
within
sir.
by Sunday or Monday, I'll just let you know. Okay.
Okay, sir.
So this is every day, right? So for the next 12 days. Okay,
Yes, sir.
12, 13 days, depending on the content that I have.
Okay, sir.
Okay.
Sir, how much attendance we must maintain?
See, it's better to maintain. I would expect a perfect attendance. Okay, 100% because it's only 1 hour, right?
Yes, sir.
And it's after your college hours, so I would expect perfect attendance.
Yes, sir. Okay, sir.
Okay, and it's only 12 days, 12, 13 days, whatever it is. If it was the entire semester or the entire year, I can understand. Maybe you will miss a few classes, something like that. But okay, so that's the thing. Okay, we'll if there are no further doubts or questions, we'll move on to the Q&A, right? Yeah. So with reference to the sustainability definition, so there is this Venn diagram actually. Okay, I don't know if this came up. I think it would have come up in one of the slides. I'm not exactly sure. So there is economic, environment, and social dimensions, right? The intersection of these three dimensions, uh, there are these four unknowns, right? A, B, C, and D. So what are these four unknowns? There are four options, but I don't know. I don't know if you guys have seen this, but it's okay. So it is A is equitable. So basically economic and social. So if it is, if a particular project or let's say a particular product is economically viable and socially viable, then it is said to be equitable. Okay. So that means to say that, okay, it is equitably distributed or something like that. Okay. One very good example of this would be the recent information revolution that we had since the last 7 or 8 years. So when Geo was introduced, okay, when Geo was introduced, it kind of just slashed the prices of all the data plans and everything. So earlier it used to cost, I think, 300 rupees per month for 1 GB for the entire month. So you will have 1 or 2 GB for the entire month for 300 rupees. Now it is like you have even in postpaid connections or something, you have 2 GB per day, right? For the same price or probably even lesser, right? So even in the villages, it's very widespread. Everyone has started using internet, so it is equitable. Okay. And so coming to, let's say, social and environmental, it is not economically viable, but it is socially viable, it is environmentally viable. Okay. And so that is bearable. Okay. So of course, it is it is bearable, but it's not economic. It costs a lot. Okay. So like I told you about the solar power plants 15 years ago, it was socially viable, it was environmentally viable, but it was not economic. It is now economic. So back then it was not. Okay. C is economic and environment. So it is viable, but then it has a lot of social issues. One example of this would be dams, the big dams that we build. So there is this huge risk of, if the dam breaks, the cities will flood, or the villages will flood. It is not exactly socially viable, but yeah, it is economical, it is environmentally friendly, so yeah, it is viable. And D, the intersection of all these three is sustainable, right? So now so read this question. So sustainable development is said to occur when? So please read this question and give an answer. I mean, which of the options is true?
C.
Yes, absolutely. Why is it C?
Because all the stakeholders are taken care of, even the
Right.
next generation also.
Yeah,
All
absolutely.
stakeholders include the society, environment, and economy also.
Yeah, perfect. That is the right answer. Okay, and because you're also taking care of one. I mean, the economical aspect, the environmental aspect, the social aspect, and the intergenerational. That is even the future. You're thinking about the future as well, right?
Yes. Yes, sir.
So, which of the following statements are false? Right? Please read the options and then give me an answer.
A is the answer.
A. Why is it A?
Because it's not education which is included, economic, environmental, and societal.
Absolutely, that is
Yes.
true. And why are the other options correct? Can you?
Yeah, because in one of your slides, I read that in few researchers, they have included institutions in to
Yes,
measure sustainability. And
yes, absolutely. It could be an additional dimension in many sustainability assessment, studies basically. So because institutional dimension is basically where they're just measuring the impacts of policies on the different dimensions of sustainability.
Mhm.
Okay, yeah. Then the other two.
Combination of indicators is called a composite indicator. Like
Yes.
whatever indicators are there, you group them into a composite indicator, and then it will
Yeah.
go through a theme.
Yeah. Theme, sub-theme, or it could lead directly to the dimension, I mean, the economic dimension or whatever it is, which is why option D is also correct.
Yes, sir.
So the only false statement is A. Now, what is the innovation chain useful for?
It's B, sir.
Yeah, why is it B? I mean, you can argue why the others are not right more in this case. Like, yeah. Can you just justify your answer? I mean, you can give the answer, you can justify it as well, right?
As well, in the other slide, you had mentioned maintaining the existing products. It doesn't only mean innovation. It doesn't only come in the
Yeah.
innovation segment. There are
Hmm.
much more things to be considered in that. And
Hmm.
one more option is removing unsuccessful products. So that was not there in the part of innovation chain. So I thought it's B, introducing new goods and services in the market.
You're right, because see, maintaining the existing products does not need any innovation as such. It is just, it's just following the process. That's it. And removing unsuccessful products from the market also does not need any innovation. It's just a natural progression. Okay, if a product is unsuccessful, it will just fade out. That's it. So, yeah, can you give me an example of when a product, I mean, why a product might be unsuccessful on what conditions, basically? This is something that I've not covered, but still, I mean, you can just think and answer. Anyone?
One reason why products are can become unsuccessful is the mm, it does not fulfill the requirements or it's not accepted by the larger population.
Yeah, an
It's not
example.
accepted
I
by the
mean,
society.
yeah, any example, like any example of a product that has been unsuccessful or
Tata Nano.
yes, that's one example.
Yes, sir.
So there is one more thing. I mean, it doesn't have to be that it becomes unsuccessful right away. It could fade out of existence. For example, you have these landline phones, right?
Yes.
It is only the government that is keeping them alive. For now, I've only seen it in the government offices right now. Okay.
Mhm. Yes.
So landline phones, especially without caller IDs and the old kind of button phones, right? So
Mhm.
those kind of phones I've not seen anywhere else. So they have faded out of existence basically. And recently, I think a few years back, this Telegram went out of existence. Not the Telegram app. I'm talking
Yes,
about the
the
Telegraph
physical
where you
telegraph.
could send, messages, and that went out of existence, right? So yeah, these
Yes.
are some of the examples, right? So yeah, so in the innovation chain, what does the research R&D, research and development, refer to?
Option D, sir. Mm. Option B. B. Sorry.
D, right?
No, it does not. Yeah, it is D. D.
Basic research. Yeah, I think
D.
so. Yeah, D is the right answer.
Yes,
So
sir.
yeah, because it
Because
includes
it
basic and
includes.
applied research. Yeah, design and development, and then you also have engineering for manufacturing. So how to manufacture this particular product or service. Okay.
Because building a prototype is much different than
Manufacturing it.
manufacturing in large scale.
Yeah, absolutely.
So,
So which of the following statements are true? You can read and anyone?
option D.
Yeah, why is it D?
I'm not clear about the full form of TBL.
Yeah, TBL is triple bottom line.
Technology. Triple bottom line. Okay.
Yeah.
It considers people, profit, and planet. Yeah.
Yes,
Yes, sir.
absolutely.
That's why it's D.
D.
And
So why is A correct?
A is correct because just like the example you gave about coal industry, like if you want to set up a coal mine, you have to consider the people living in that area also. Even they are the
Yeah.
stakeholders.
Yeah, but this is not stakeholders. This talks about shareholders, right?
Okay. Yeah.
Yeah. So
Shareholders.
yeah, shareholders, and obviously they are given the utmost importance in a profit-based approach, where you fulfill your investors'
Based on the investment
requirement
return,
first.
want returns.
Yeah.
Yes.
Right.
Yes.
So that's why D is correct. Now you can go through this. So basically, there is an industry that produces something, okay, and the production process has a harmful chemical, okay, and this chemical causes human cancer upon prolonged contact, and if it is discharged into water bodies, it contaminates drinking water sources and destroys the marine ecosystems. Okay, so you can treat this chemical before discharging it, but that will cost some money, of course, but it will also reduce its effects on humans and ecosystems. So which of the following measures the company can take? I mean, it denotes a triple bottom line approach. So you can read
C.
the options.
C.
Yeah, why is it C?
Because here they not only they think about all the aspects here. They are
Right.
thinking about their workers by giving them protective equipment,
Yeah.
and they are considering the environment also by having a treatment plant,
Mhm.
and they are considering the society also, which focuses more on like it'll have a higher impact if you market your product as a sustainable product.
Yeah. So, and why is it not D?
Why is it not D?
Yeah.
Because it's not focusing on the society, where it's not focusing on economy actually. Uh, no, sorry,
Increasing the
Kind
society.
of.
Yeah,
Kind of.
because they
I
are
mean, you can argue
increasing the
that they
selling price.
are uh, yeah, they're not mutually exclusive actually. Okay.
Yes.
So what happens is if you can increase the cost. Wait 1 second. Yeah. So you can argue that both are not mutually exclusive, right? You can increase the cost, but then it's not actually serving the purpose for the consumers who are also stakeholders in your uh, project or in your event base.
Yes, sir.
Yeah. Then you have this question, number 8. Number of hospital beds per 10,000 people in Bangalore is 22. So if the best and worst values of hypothetical cities are 137 and 3, then find the normalized value of this indicator.
Option B, 0.14.
Yeah, have you calculated it or?
Calculated.
Okay, how did you calculate?
The actual value 22 minus the minimum value divided by
Right.
maximum value minus minimum value.
Yes, absolutely. That's right. Because yeah, that's the normalized score. So it's not very great, right? Compared to the best and the worst cities. So we are somewhere in the bottom actually in Bangalore. Again, this is from 2013. It could have improved now. So someone has to do this research again, right?
Yes, sir.
So yeah, so that's it I have for today. So in case you have anything, please let me know in case you have some questions or something. Anyone?
Sir, are you going to share the slides?
I'll share the slides. Yeah,
Okay, thank you,
I'll
sir.
share it on the group. Okay, on the WhatsApp group.
Yeah, sure, sir. Thank you, sir.
Okay. Anything else?
No, sir.
Okay, so thank you so much for joining. So
Yes, sir.
we'll meet again tomorrow at 7 o'clock. Okay.